Okay, hi guys. So in this lecture, we'll be discussing on Maxwell's distribution curve. So let's get started. Maxwell's distribution curve. Okay. So first, let's see what is Maxwell's equation. So Maxwell's equation is dnu is equals to 4 pi n times m over 2 pi rt to the power 3 by 2 times e to the power minus mu square upon 2rt times du. Okay, so we can write first here that dn by n is fraction of molecules having speed between u to u plus du. Okay, fraction of molecules having speed between u to u plus du. Okay, and 1 upon n du, or rather dn by du, represents fraction of molecules having speed between u plus u to u plus du per unit internal, or rather per unit interval of speed. Okay, fraction of molecules having speed between u to u plus du per unit interval of speed. Okay, so let's see a graph between fraction of molecules which is 1 upon n dn by du with u. Okay, so here we can write that this is the graph. Okay, and in this graph we can write that at this point of time e to the power minus mu square, or rather we can write it at e to the power minus x term in 1 upon n dn by du dominates, and in the upward sloping curve u square factor dominates. Okay, so this is the small portion here which is du. Okay, so molecules having very less and very high speed are actually very small, you can see from the graph. Okay, so this goes on with something like this. So the molecules having very high speed is very less, and molecules having very low speed is also very less. Okay, so for a particular gas we can represent the graph something like this, that for a particular gas we can have the graph as something like this. And for another one it can be something like this. Okay, again on the y-axis we have fraction of molecules, x-axis we have u or speed. Okay, So the graph could be different depending upon the temperature. This is at temperature T1 and this graph is at temperature T2, and T2 is greater than T1. Why? Because we can see that majority of the fraction of molecules have a higher U or U average, or whatever term you may want to have. It can be VRMS or URMS or UMP or U average, as the kinetic energy of the molecules would be higher. That implies that as kinetic energy is directly proportional to the temperature, T2 would be higher than T1. That's why the graph is shifting towards a greater value of U. Okay, so after this, let's actually define some terms to have to represent the velocity of the molecules or gaseous molecules. So first, VRMS is root of 3RT upon m. Then we have V mean, or we can write that this is the most probable speed of molecules, that is 2RT upon m. And then we have V average, or the average speed of all the molecules, which is nothing but 8RT upon pi m. Okay, so in a sense we can write that heavy gas particles, or rather heavy gas molecules, or molecules with which are having higher molar mass, will move slowly, and light gas molecules actually move fast. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing more theory on the velocity of gas particles or gas molecules. So till then, good luck and goodbye.